to look at number 3. So we're going to go through and do the ones that you guys have requested, starting with the first one in order, which would be number 3. And this is that large factoring problem. Essentially what you have here is that there's a plus sign separating this left side from this right side. So what we're trying to do is find a GCF across both parts so that we can factor it out. So some things that you can do first is that anything that's just a regular old number, you could multiply together just on the left side, and over here we can do that as well on the right side. So this would be -6, and then we'd still have our 3x plus 1 to the 6th. It's coming from right here. We have our 2x minus 5 to the -4. We also have now our plus sign, and then we have 6 times 3, which is 18. And then we bring down the other two terms. So that is a 2x minus 5 to the -3 and a 3x plus 1 to the 5th power. Okay, once you get to this point, now you're looking for that actual GCF. So this just cleaned up a little bit of the clutter. So look at your numbers first. -6 and 18 are both divisible by -6, and I usually pull out a negative if it's first. So that would be -6. Let's see, what else do we have in common? We have 5 3x plus 1s that we can pull out. And anytime you're pulling out common things like common bases, when you're looking at what do they have in common, it's always the smaller number. So even though this looks weird, -4 is actually smaller than -3. So we're going to pull that out to the front as well. So that's going to leave us with a bracket, and we have to individually determine what's left in each piece. So -6 divided by itself is just a 1. 3x plus 1 to the 6, we pulled out 5, so we still have a 3x plus 1. It would just be to the first power. We pulled out all -4 of those, so those are gone. Then 18 divided by -6 would be -3. Here's where it gets a little weird because this is -3. That's actually 1 more than -4. So you will still have a 2x minus 5 in your inside here, and we pulled out all 5 of the 3x plus 1s. So once you've done the GCF part, so this is what we just pulled out, all you have to do to finish this problem is 2 things. You need to clean up the inside of the bracket, and you need to move the negative exponent to the bottom. So let's clean this up first. So this would be 3x plus 1 minus 6x plus 15 if we distribute. Combining like terms would be -3x and positive 16. So for my final answer, I have a -6 up top, a 3x plus 1 to the 5th power. I'm not going to write this guy yet because he's going to go to the bottom. A -3x plus 16, that's from what I just did in the bracket, and that's all going to be over 2x minus 5 to the 4th, because now that has a positive exponent since it's moved to the denominator. Okay, so before I move on, is questions, concerns about that one, or are we okay? And Virginia, I did see your request. We're going to go back up and do number 1 as well. Angel, are we okay? And Lewis? Okay. Let's go up to number 1 because Virginia requested that one as I started working. This has no exponents on the outside. If it did, this would actually be a harder problem. And like I said, whatever level difficulty we are giving you right now, that's what we expect you to know. So if there's no exponents on the outside, you can go straight to multiplication. So 5 times 4 would be 20. X squared times x to the -5. Remember, when you multiply, you add exponents. So that would be x to the -3. And y to the -3 times y to the 4th. Again, you add exponents, so that'd be y to the +1. The only thing we need to do to fix that one is move the x to the 3rd to the bottom. So that one's actually much easier than number 3. Is that okay? Does that clarify your question on that one? Okay. I believe our next one was number 8, so let me scroll down to that. Yes. Okay, for number 8, it says solve using the quadratic formula, which means we have to do, remember our little guy, I'm not going to sing him right now because it would sound horrible, but negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's how we solve a quadratic that does not factor. So the big thing about this is if you leave this the way it is, a would be 1/8, b would be 4/5, and c would be -1. I have no desire to plug fractions into a radical or another fraction. So since this is an equation, if you can find an LCD, you can clear the fraction. So the LCD here would be 40 because 40 goes into 8 and 5 both go into 40. So we're going to multiply all 3 of the numbers on the left by 40 because you have to do it all the way across to be equal, and then on the right side as well. So the reason we did this is because things are going to cancel. So 8 goes into 40 5 times. 5 times 1 is still 5. 5 goes into 40 8 times. 8 times positive 4 would be positive 32x. And 40 times -1 would be -40. Oh, what was that? And then 40 times 0 is 0. So now this is my A, this is my B, and my C is -40. So that's a lot easier. I mean, they're big numbers, but it's easier than plugging in the fraction. So we would say x equals -b plus or minus square root b squared minus 4ac all over 2a. Okay, so let's work this out. So let me get my calculator. So we want to do 32 squared, which is 1,024. I'm just writing it above because I don't have a lot of room. And then -4 times 5 is -20, and 20 times -40, because those are both negative, would be a positive 800. So now I have x equals -32 plus or minus, since this was a positive once you worked out the negative signs, we have to add. So that's 1824 under the radical, and this is 10. It looks very suspicious to me that this one probably reduces of some kind. So let's see, what goes into this big number? A perfect square that goes into it. I wonder if 16 does. Yes. Does this go down further though? No. Because I believe, yeah, none of those are matches after that point. So it looks like 16 is the biggest number that goes into that. Now you would have to go through all of your perfect squares leading up to that to make sure. But if you can, feel pretty good about the one you've picked, you should be okay. Just make sure the inside part doesn't reduce down anymore. So this would be a 16 times a 114. That's what's inside that radical. So this is -32 plus or minus square root of 16 is 4. That would be square root of 114 still over 10, and then everything outside you have to check. If all 3 of them are divisible by something, you need to reduce. So all 3 of these are divisible by 2. So that would be -16 plus or minus 2 on the square root of 114 over 5. And that is 2 separate solutions, but we can write it as 1. It's fine to leave it as a plus or minus. Is everybody okay with that one? Angel, you good? I think this was your question, wasn't it? Okay. Yeah, so when you're reducing this, you have to make sure the radical's reduced. And anything that comes out, you always check these three little numbers right here. If they have a common factor, it reduces down again. If they don't all three have a common factor, it's done. Okay, let's look at our next one on our list. I believe it is 14D. Yep. Okay, so I need to see my points. We're supposed to find the equation of the perpendicular bisector through a line segment AB. AB is connected to the 2 points that were given to us. And our final answer should be in standard or general form. That's the same name. So the first thing you have to realize is that you need a perpendicular slope because of the word perpendicular, and bisector means midpoint. So we're going to need to know slope information, and we're going to need to know a midpoint. So we can go ahead and do the slope. I'm going to do my work up here for that. This is 2 minus negative 3, because y2 minus y1, over 6 minus 4. That would be 2 plus 3, so that's 5, over 2. This is the slope of AB. We want to be perpendicular to AB. So my perpendicular slope that I'm actually going to use is negative 2 over 5, because remember, you flip the fraction and change the sign. So this is going to be important for the actual equation. The midpoint you find by adding the x's, cutting them in half, adding the y's, cutting them in half. Essentially, you just take an average of each part. So 4 plus 6 divided by 2, negative 3 plus 2 divided by 2. So this would be 10 over 2 and negative 1 over 2. So my midpoint is positive 5 comma negative 1/2. I'm going to need this information as well. So now, because this is the bisector, not the actual segment AB, we don't use anything else about these 2 points. We use the points to find the slope and make it perpendicular, and we use the 2 points to find the midpoint, which a perpendicular bisector looks like this. So here's A and B, and here's this thing coming down. It cuts this in equal halves and it hits at 90 degrees. So this is the actual equation we're looking for the equation of, okay? So we use our midpoint and our slope that's perpendicular. And remember, anytime you want to write an equation that's a line, you have a formula called point slope. It would be y minus y1, so that'd be y minus negative 1/2, so that'd be y plus 1/2, equals negative 2/5 x minus 5. I would want to, I guess I could distribute this fraction first. So y plus 1/2 equals negative 2/5 x. The reason I decided to distribute is because the 5s are going to cancel, but it's a negative 2 times a negative 5, which makes positive 10 divided by 5. So it's actually going to be positive 2. Now we want this in general form, which means we can't leave it with fractions. So we actually need to multiply everything by 10 to get rid of all the little fractions, because 2 and 5 both go into 10. So this would be 10y, half of 10 is 5. 10 divided by 5 is 2. 2 times negative 2 would be negative 4x. 10 times 2 is 20. And our final step is to put this into general format, which means x and y go on the same side, constants go on the other side. So if I move the 4x over, it would become a positive 4x, a plus 10y because it didn't move, and then the 5 would subtract over, so it would be positive 15. So that would be the answer to 14D. Is that one okay for everybody? Lewis, are you okay with this one? Okay. Just making sure we're all good before we move on. So moving on down the line, I believe the next question was in the 20s. Let's see. 21. Okay. This is graphing a polynomial. Notice that there's no fraction, so it's not rational. No weird absolute value symbols, no radical signs. This is just a polynomial. Polynomials always have what we call a smooth continuous curve. So just kind of reteaching a little bit before we get started so you know why I'm doing it the way I'm doing it. In a smooth continuous curve, you start at one point and you go up and down, up and down, and up and down until you go towards infinity in one direction. This is actually one that starts with an odd degree. If you have an even degree, you end and start the same way. So notice this was down and up. This is up and up. So this one is actually an even degree. And that just references your highest power. So you don't have to know that to be able to graph this at all, but it does help you check your answer at the end. And the most you can turn or flip back and forth is, remember, one less than your power. So actually both of these have way too many squiggles for this guy. So one thing I would suggest, first of all, is if it's not factored, try factoring it. So this is 4 terms, so I'm going to do factor by grouping. And before I get too far, let me actually save what I have commented on this first, because sometimes the computer doesn't like me towards the end. So let me save that real quick. Okay, so if we pull an x squared out of the first pair, that would give us an x plus 2 left over. The second pair starts with a negative, so we're going to pull out a negative, and they're both divisible by 4. So that would also leave me with an x plus 2 because you divided -8 by -4. We would see that the x plus 2 matches, so that would come to the front. And we'd be left with an x squared minus 4, which also still factors. So we want to go all the way with the factoring. So this is an x plus 2 from this part. And then we also get an x plus 2 and an x minus 2 from this perfect square. So it looks like we actually have x plus 2 squared and x minus 2. So that means we have 2 x-intercepts, because in a polynomial, x-intercepts happen at the factors that are real numbers. So my 2 x-intercepts are 2 and -2. Actually, this looks a little confusing. I'm going to write the word 2, because one of our x-intercepts is actually positive 2. So -2 and 2 are going to be my 2 x-intercepts. Once you've determined that, there's a couple ways you could graph this. We taught you to look at the multiplicities, which is the power on the factors, and knowing about odd and even and leading coefficients. Honestly, that's a lot of work to try to remember. If you already know how to do a table, and we've done the charts quite a bit for a couple other things, it's probably better to stick with this method. So if you make a number line, just kind of matching up with this, you place the x-intercepts from least to greatest. And these are where we're going to equal 0, essentially. The negative infinity to -2 would be the left side of that. -2 to 2 is the middle, and 2 to infinity is the right side. These are representing chunks on the number line, either to the left of a point or to the right of a point. So for example, I already know that these 2 points are on my graph because they're my x-intercepts. So we pick a test value in each region. So this would be maybe -3, 0, and +3. We have to be careful. If it was me, I would list all of my factors instead of trying to write x plus 2 squared, because you might plug in incorrectly if you do that. So I actually have 3 factors altogether, 2 x plus 2's and an x minus 2. So we're just going to go through and check our signs. -3 plus 2 is negative. -3 plus 2 is also still negative. -3 minus 2 is negative. So this is 3 negatives, which stays negative. 0 plus 2 is positive. 0 plus 2 is positive. 0 minus 2 is negative. 1 negative is actually negative. 3 plus 2 is positive, 3 plus 2 is positive, and 3 minus 2 is positive. 3 positives make a positive. What this actually tells you is that both of these guys are going to be below the x-axis. This one's going to be above. So if you graph this, this is, remember, your x-intercept. So use these as your reference points. On the left of -2, we need to go below, so we go down. Between -2 and 2, we should also be below. That means this is a bounce. It actually hits the line, goes down, and then starts coming back up. At the right side of +2, we should be above, so we do continue on towards infinity. The final part of this on the exam, once you've got your picture drawn, is they ask you these two questions, and there's a blank for each. If you've done the chart, the pluses are this one, the minuses are the less than case. So the above would just be 2 to infinity, so that's this guy, and the below would be -infinity to -2, unioned with -2 to 2. And that would have its own blank on the test for each of those. Okay, that one was kind of a long one. Let you have a second and let me know when you're good. Okay, let's move on to our next one. Number 23. I like this one. I'm glad someone asked this one. This is the find all the solutions of the equation. It's also a polynomial. If it graphed, that would make this like 1,000 times easier, or excuse me, not graphed, if it factored. If this factored, it would make this 1,000 times easier to solve. The one on test 3 was factorable, so you actually didn't have to do the C over D list at all, because you could have completely factored it. This one is not factorable. The reason I know that is if I try to pull out like terms for, or not like terms, GCFs for both of these pairs, this would give me an x squared, but a 2x minus 11, and this would give me, pull out a -5, that'd be an x minus 10. Notice those don't match, so you can't factor this, at least not the typical way. So anytime we're trying to solve this type, we need to make our C's over D list. That's called the potential rational roots. So C is the factors of 50, and D is the factors of 2. So I'm going to do that kind of over to this top part up here. So C is factors of 50. Okay, so we have to think through that. Plus or minus 1. 2 goes into it. 3 does not. 4 does not. 5 goes into it. So plus or minus 5. 6 does not. 7 does not. 8 does not. 10 does. And now we're at the point where we know we've got everything. We just need to know the pairs. 25 and 1 times 50. Okay, and then D's would be factors of 2. So that's just plus or minus 1 and plus or minus 2. The whole point of this is that this list gives you some possibilities for your numerator and your denominator in your list. So all of the C's get written over all of the D's. We only write something once, so if it reduces down to something you've already written, you don't write it again. So you start out with the first C and you put it over 1, and I'm actually going to do all of them over 1 before I move on to 2. So 1 over, and I'm just going to write 1 plus or minus out front. So 1 over 1 is just 1, 2 over 1 is 2, 5 over 1 is 5, 10 over 1 is 10, 25 over 1 is 25, 50 over 1 is 50. Then we go through and put them all over the 2. So a half. 2 over 2 is actually 1. We already got that guy. 5 over 2 is new, because that's a fraction. 10 over 2 is 5, which we've already listed. 25 over 2 is new, because that doesn't divide evenly. And 50 over 2 is 25. So this is my list, okay? Now the whole point of doing this is that we will then try to use what's called the factor/remainder theorem to find a potential 0 that actually does give you 0 when you do the division. You don't want to start out doing the synthetic division first, because you could do a lot of paperwork and not get many places. So the way we check this to see what the answer is going to be is we plug it into the function. So we're going to start off with positive 1. That's just typical. We plug it into here. So 2 times 1 cubed minus 11 times 1 squared minus 5 times 1 plus 50. We work this out. So 1 cubed is 1 times 2 is 2. 1 squared is 1 times negative 11 is negative 11. Negative 5 times 1 is negative 5 and plus 50. If this does not equal 0, you don't want to use this number. So it looks like that's negative 16 and 52. That is not equaling 0. So that means the positive 1 is not the answer we're looking for. So we'll try negative 1. So then we plug it in for all the x's. Okay, we're going to work through this. Negative 1 cubed is negative, times 2 would be negative 2. Negative 1 squared is positive, but times negative 11 makes it negative. Negative 1 times negative 5 is positive 5, and we still have our positive 50. That's 55 minus 13. That is not 0. All right, so let's try positive 2 next. And hopefully the point of doing it in order like this is that you'll find the answer hopefully in the whole numbers or the integers first before having to go to the fractions. But sometimes it's a fraction, so you just have to keep trugging through. Usually on a test situation like this, we're going to give you one that you find an answer pretty quickly. So 2 times 2 cubed, and you are going to have your calculator, so, and then negative 11 times 2 squared minus 5 times 2 plus 50. This is 8 times another 2 would be 16. 4 times negative 11 would be negative 44. 2 times negative 5 is negative 10, and then I have plus 50. This looks like a very close, but maybe not, because that's negative 54, and that's 66. So that's close, but not quite. Unless I missed a sign, I don't think I did. All right, let's try negative 2 then. So this would be 2 times negative 2 cubed minus 11 times negative 2 squared minus 5 times negative 2 plus 50. This guy is negative 8 times 2 is negative 16. Negative 2 squared is 4 times negative 11 would be negative 44. This turns out to be positive 10 this time and positive 50. This is 60 and negative 60, so yay, we found it. All right, so a lot of work, and all that did was tell us that we found one that's going to make this reduce down by a degree. And I'm going to have to write into the 24 one a little bit because there's no other way to write around this or add space at this point. It's a PDF. So the next step is you take this number that worked, which was negative 2, and you plug it into synthetic division using these coefficients. So this is 2, negative 11, negative 5, and 50. Move that D over a little bit. Okay, so we bring down the first number when we do synthetic division. So this would just be a 2. Then you multiply by the factor out, or the 0 out front. So this is negative 2 times 2, which is negative 4. You add it, so that's negative 15. Multiply, that's 30. Add, that's 25. Multiply, that's negative 50. And we expected this. It comes out to 0. Why we did that is because this now gives you a quadratic instead of a third power. So now I have 2x squared minus 15x plus 25 equals 0. We do already know that negative 2 is a solution to the final answer, so I'm going to go ahead and write that right there because that's what worked here. And then we need to try to factor this possibly because I hope we don't have to do the list again. Or you could just do quadratic formula. So if it's quadratic, you could either try to factor or just do quadratic formula. But I believe this will actually factor. So 2 times 25 is 50. Factors of 50 It looks like 5 and 10 could work. They have to both make positive 25 when they multiply, excuse me, positive 50 when they multiply. And then they have to add to negative 15. So it looks like it's going to be a negative 5 and a negative 10. So maybe put the negative 10 first. So this is squared. So that's 2x you can pull out to the front, and that leaves you with an x minus 5. Pull out a negative 5, and that leaves you with x minus 5. Oh, I don't know what that is. Oh no. All right. Give me a second. Technical difficulties, and that one will probably have to be reworked later on so that you guys can see all the work, because I'm guessing it didn't save it. Oh, it saved most of it. Okay. I will retype all of that in or write it in and at the end once we're done. But I was at the point where I had, I'll just write it down here, 2x squared minus 10x minus 5x plus 25, and we were factoring that. And that is x minus 5 and 2x minus 5. So my other two solutions are 5 and 5/2, because you'd add 5 and divide by 2. So my three solutions altogether were negative 2, 5, and 5/2. So that is the answer to number 23. Sorry about the technical difficulties. Sometimes this program locks up with all of the ink. Save myself a little bit of work. Any questions on this one while I'm finishing that part out? Are we good?
So I had a quick question.
Sure.
Why isn't there's another number that makes it 0? So when we only find one that makes it 0, we stop from there.
Because this is a third power, so as soon as you find one, you are guaranteed to be able to do synthetic division. Synthetic division allows you to reduce your polynomial by a single degree. So as soon as you have a quadratic, you no longer need to do this. You could keep going with this method. It's just overkill. You don't need to do it if you've got a quadratic, because you can just do quadratic formula in a worst case scenario.
Okay, but so I don't like keep going and find more zeros. I stop when I find
As soon as you find the first one, that's the one you use to do the synthetic division, and we give you a third power one if we give you one on the test. So you should only have to do the process until you find one, plug it into synthetic division, and then factor out what's left, or possibly quadratic formula if it doesn't factor. But we're going to be nice to you on the test. I mean, you can't go all through all this work and then do quadratic formula. We've already tested you on quadratic formula with one of the other problems. So this one's going to be factorable.
Okay, perfect. Thank you.
Any other questions about this one? I think I've almost got it caught back up to where it should be on the ink part. There we go. So this guy was 2x squared minus 15x plus 25. Perfect. Okay. Everybody good? Angel, we good? Okay. So I'm going to kind of block this off a little bit. I'm going to save my work first. I do not want to have to rewrite that again. I'm going to block this off a little bit so that this is all very clearly still tied to number 23. Okay, so 24 was also asked. This is graphing a rational because notice it has x's in its denominator. This is the case when you want to know about vertical asymptotes, x-intercepts, holes, horizontal asymptotes, obliques, and a y-intercept. Essentially, when you see a stacked fraction and it says graph, or sketch is usually the word they should use, but we sometimes use graph in the book. It still means just for us get a rough sketch. we want to know these 1, 2, 3, 4, 5, 6 things, okay? To figure them out, you first ask if this is completely factored, because if it's not, you would want to factor it first to figure out all the different pieces. If it's factored and nothing cancels out, and by the way, 4 and 6 do not cancel out because they are not similar. I know they're both divisible by 2, but this is a binomial and this is a monomial. That's partial canceling and you can't do that. So if nothing cancels, any x values that would be on top would be x-intercepts. Any x values that are on the bottom are a vertical asymptote. If something were to cancel, it would have caused a hole. So since nothing cancels, I can go ahead and write none on a hole. If you had a hole, you just draw an open circle where the hole is. And like I said, this is the level of difficulty you should expect. I have no x-intercepts, so I don't touch the x-axis at all because this guy has no x's on top. Because if you had an x, you'd have an x-intercept. I do have a vertical asymptote, and it would be x equals 6. Remember, it's a vertical line, so it's just solving this over and writing the equation. Okay, so that's what I know so far. So if I wanted to, I could graph some of this information. So 1, 2, 3, 4, 5, 6. There's my vertical asymptote, and that's pretty much the only thing I have on the grid as of right now. Okay, to find your y-intercept, that's the next easiest piece. You plug in 0 for your x. And we reduce, which would make this 0, negative 2/3. So I do have a y-intercept, and that's going to be a little bit above -1 on the y-axis. The horizontal versus oblique thing is a question of can you do division with this problem. If you can do division, which means that you either have a smaller power on bottom or you have the same power of x on top and bottom, then you either get an oblique or a horizontal depending on which case it is. So the rules were if the top was smaller than the bottom for degree, that means the highest power of x, then you get y equals 0 because you can't divide. X does not go into 4. If the top is equal to the bottom, you just put, it's still a horizontal asymptote, it's just the leading coefficient of top over the leading coefficient of the bottom. And if the top is greater than the bottom, that's when it's an oblique, and that's when you have to do long division. We are not giving you this guy on the test. It's going to either be one of the first two cases. So this is a none, and this guy is actually y equals 0. So we can graph a dashed line for that asymptote. So there's y equals 0. This guy is x equals 6. Now, I already know what's happening on my graph down here. We're also not going to give you one that crosses your horizontal asymptote. So again, we're giving you the most basic rational function we can. Because this point is south of this dashed line, it cannot rise above this as long as it can't cross its horizontal asymptote. If you want to know how to check that, remember you set this number equal to this. If you cross multiply, you get 0 equals 4 because that would cancel all that out. That doesn't make any sense. There's no x left over. So that means it doesn't cross. So this guy is stuck traveling along towards his asymptote in this direction. And he travels along his asymptote in this direction and eventually starts realizing there's a wall ahead. And he starts going down because he can't go up because this guy right here is blocking him. So that's what's going to go on down here. To prove that to yourself, remember you can always pick x values over here like 3 or 2 or 1 or -5, whatever you want to pick, plug them into the function and get actual points. If that makes you feel more comfortable, do it that way. Okay? You don't have to just go by what I'm saying. You can always plot as many points as you're comfortable with. You do still have to have graph on the right side. The only place this graph is allowed to have a glitch is at +6. That means there is graph somewhere over here. We don't know if it's on top or bottom, so we do have to pick a point. So I'm going to pick 7 because that's right over on the other side of 6. So if we plug in 7, this would be 4 over 7 minus 6, which is 4 over 1, which is just 4. So this is the point 7, 4. That means this guy has to be trapped up here in the top region. He can't cross either asymptote, but he just travels along them. So this is what the graph would look like for this one. Now I know the answer key might look slightly different because the graph probably got scaled a little bit differently to make it so that it's more centered, but this is essentially the points. Any questions on that one? Okay. And I think, did we have one more? Let me scroll down and see. That was it. That's all you guys asked. So let me open it back up because I can stick around for another 15 minutes if there's something else you want to see or ask me. So is there anything else maybe we skipped over that you would like to talk about? Okay, number 26. I'm going to go ahead and circle that. How about you, Angel or Lewis? Do y'all have any other ones that you would like to throw at me? Angel's good. Okay, I'll let you have a look for a second. Let's go ahead and look at this number 26. This guy does not have same bases yet, but you do have to check to see if it could. If you can get the same base, then you don't need to use a logarithm. So what I'm thinking of is what are numbers smaller than this that both of these can turn into? So think about 4 maybe. 4 to the first power is 4. 4 to the second power is 16, and 4 to the third power is 64. So we could rewrite 64 as 4 to the third, and then you have a 3x plus 2 still on the outside of that because this is just replacing that base. And then you have 4 squared for 16, which still has its x minus 1 on the outside. Anytime you have power, you multiply the powers. So this would be 4 to the 9x plus 6, and this would be equal to 4 to the 2x minus 2 because we're distributing that 2. If the same base matches, you set the inside or the exponents equal. So 9x plus 6 equals 2x minus 2. Subtract the 2x over. This would be 7x plus 6 equals negative 2. Subtract the 6. And then we divide and we get negative 8 over 7. So that is the answer to number 26. I saw a request for number 27 and a couple others too. 18 and 20C. Okay. Are we okay with 26 before I move down to 27 though? Everybody okay with 26? Okay. For 27, you're graphing this and it says dash in any asymptotes and plot at least 3 points. This is an exponential. It has a base, remember, of this special number. Remember, E is on your calculator. So you're going to have your calculator to do this one. We're going to make a table of values. We are picking the x's this time because remember this is just a regular exponential. If it was a log we were graphing, we would convert it to exponential form first and we'd be picking y's. But this one's pretty straightforward. The only thing I will note is that your middle part of your chart, you always want that to have an exponent of 0. So if you want this exponent to turn into 0, you're going to have to start with negative 3 in the middle of your chart because negative 3 plus 3 would equal 0. That is the first thing I always check to see if there's anything keeping me from equaling 0 very simply by looking at the exponent. Then once you get that, you pick 2 numbers bigger and 2 numbers smaller. just to get a good variety. And that also helps because then it double checks your math. So this would be e to the negative 1 plus 3 and then plus 1, e to the negative 2 plus 3 and then plus 1, e to the negative 3 plus 3 plus 1, e to the negative 4 plus 3 plus 1, and e to the negative 5 plus 3 plus 1. Okay, so I'm just going to get my calculator out because there's no other way. No, Virginia, if you pick positive numbers, you're not going to get a good graph because this guy is not, you're going to get really crazy values. They're either going to be too tiny or too large. You have to keep yourself centered as 0 as your main exponent in this middle part. So if this was just an x, yeah, you could pick 0, 1, 2, -1, and -2. But because it's got a +3, you need to adjust that. Otherwise, your graph's not going to make sense. So then let's just work this out. This would be e to the second power. So I believe I have to use my shift button. So e squared plus 1. I'm getting 8.4 as an approximation for that. This next one will be e to the first power and then plus 1. So that'd be 3.7. This is e to the 0, so that's just 1, and then plus 1 would be 2. This would be e to the negative 1. So 1 negative e. And plus 1, which makes it 1.4. And this would be e to the negative 2. And then plus 1, which is 1.1. So if you notice, this guy's getting closer to 1, but not actually touching 1. That's because this guy is his asymptote. Exponentials always have the vertical shift as their asymptote changer. So this would be -1, 8.4, which is going to be somewhere way up here. I'm not going to graph that one. -2, 3.7. -3, +2. -4, 1.4. -5, 1.1. And I notice now I can see my shape of my exponential. Not quite perfect, but. And then the asymptote would be right here at +1. So notice this has been shifted up 1, which did change the asymptote, but it's also been shifted left 3, which changes where the shape occurs. If you'd picked positive numbers, you would have had things way up here in the sky. And no, you do not need to turn in the final review for points. I want you guys to keep it and use it as much as possible. You've already turned in 3 reviews, which was a substantial amount of work anyways. Are we okay with this one? Okay, let me go back to 18, I think it was, and 20C. Let me go back up in my list. Yes. Okay. I'm going to save this so far. All right, so this is a piecewise function. I believe I'm on 18, aren't I? Yes, okay. So piecewise functions, don't make them hard. It's just 3 table of values. So the first table of values is for the first function listed. The second table is for the middle one. And the third table is for the last one. You don't just get to pick whatever x's you want. You have directions over here. For this first function, you go from -2 to +1. You do use the endpoints, but you do have to determine if they're opened or closed. In this case, this has no equal to, so this will be an open circle. This one has an equal to, so this will be closed. This guy goes from 1 to 3, so I'm just going to go ahead and set up the table. Neither one have equal to, so the endpoints are open. And this one is from 3 to infinity, so just pick a few things. And the 3 is closed. Sometimes it's nice to write a little note that this goes to infinity so you know to keep drawing the graph. So now we're just going to plug these in. So negative 2 times negative 2, because I'm squaring it, is 4, times 2 would be 8. Negative 1 squared is 1, times 2 is 2. 0 squared is 0, times 2 is 0. 1 squared is 1, times 2 is 2. I go ahead and plot all of these and finish this section. So negative 2 and then up 1, 2, 3, 4, 5, 6, 7, 8. And that is an open circle. Negative 1, positive 2 is just a point. 0, 0 is another point in the middle of this graph. And then 1, 2 is the closed ending point. So notice this is a parabola from this point that we started at the top all the way down to the 0, 0 and then back up. And yeah, I can't draw straight on this pen, so that's what it is. For this guy, we plug in these numbers. So 1 minus 3 is negative 2. 2 minus 3 is negative 1. 3 minus 3 is 0. Go ahead and plot them. 1, negative 2 is an open endpoint because of the not having an equal to. 2, negative 1 is just a point in the middle of these 2 points. And then 3, 0 is the other endpoint, and it's also open. So this is a part of a line, which makes sense because this is mx plus b, and this has got a x squared. So they kind of map to their shapes. This last guy is always 4. There's no x. This always comes out to 4, no matter what your number is, because there's nothing to change. So this would be 3, 4, and it's a closed circle. And then 4, 4, and 5, 4, and it keeps going like this forever. So it is a continuing horizontal line. So that would be the graph for number 18. Everybody okay with that one? Yes, on these, Angel, it's whether or not it has the equal to bar. So whichever inequality the number is closest to, that's the one that it gets its behavior from. That's why on this case, this one's open, but this is closed. All right, let's look at 20C. I'm surprised you guys didn't ask for 19. Are we sure we don't want to see 19? I expected this one in the list tonight. Okay. Let's do 19, then we'll do 20, because this is kind of a, it's a graphing one, so it kind of sticks with that similar idea. This says take this quadratic and make it look like this. Anytime you go from a quadratic that is in standard form to something with a part squared, that is completing the square. And this is the only time we test you on completing the square. So it's definitely going to show up on this test because that was a big thing that popped up a couple different times throughout the semester. So the problem with completing the square is you have to have a 1 in front of the x squared. Now we have this weird f of x over here. And so I just want to make sure you realize that you don't really want to move things over to the left. So everything we do, we're going to do it to the right. So we're going to pull a negative 3 out. And then we would have x squared minus, or excuse me, plus, because I pulled the negative out, 2x. I'm leaving a space for a nice trinomial to be created, and then this minus 5 is just going to be left over as a kind of a constant to the outside. So you have this space that you're holding to complete the square. And then we take half of the middle number and square it, which would be 1 squared, which is 1. You add that number right inside here. Okay, you want to counter that on the outside. Since you're on the same side of the equation, whatever you do here, we want it to be canceled out so that it's like we really added 0. Now, the problem is most people will put a minus 1 here. You didn't really add 1. You have this negative 3 out front here. You really subtracted 3 because negative 3 times positive 1 is negative 3. So to counter that, you need to do a positive 3. So that's what's going to go right here. If we were to distribute that out, that -3 and that +3 would cancel out and we'd go back to our original. But we don't want to do that. That's why we have to do it that way. Now, if we've done this correctly, this is just going to factor. So this says -3. This is x plus 1 times x plus 1, so that'd be x plus 1 squared. And -5 plus 3 is -2. So this is one part of your answer. That's vertex form. The nice reason for this is that we can pick the vertex out of our parabola right away. It's the opposite of this. In other words, what would make this 0? So that's -1, and exactly what you see here, so -2. So opposite of the x, exactly the y. Okay, so that's the relationship for the vertex. So if we plot this, this would be -1 down 2, so I'm going to mark that as v. That doesn't give me a lot. I do know at least that this parabola is going down because it's negative. Out front, if it was positive, it would be going up. If you can find just one point on either side, there's a mirror image on the other side. That gives you 3 points. So I'm going to actually plug in 0 for x. That just makes sense to me. And I'm going to plug it back into the original because that makes more sense as well. So if I plug in 0 for all the x's, you notice you just get -5. So 0, -5 is another point on that parabola, which means there's also a point. So notice this guy is 1 away from the vertex and down 3. So 1 away from the vertex on the other side and down 3, there's a mirror image. So there is my parabola. Any questions on 19? I know we did it in your class, Virginia, but I don't think we got to this one in my afternoon class. Or if we did, I don't remember. All right, that leaves us with 20C. Okay, so 20C is the composition of two functions. Here are our two functions. We're supposed to be doing f of g of x because the g is closest to the x. If it was g of f, we'd be doing g of f of x. The reason you have to write this correctly is you have to know which one is the shell and which one is getting plugged in. F is the outside, so it is the shell. So you actually go through and talk about f as if his x's are missing. So 2 times blank over blank minus 4. So now he's a shell. Inside that shell, we plug in the interior function, which is the x over x plus 5. We could clean this up a little bit. On top, that would be 2x over x plus 5 over x plus 5 minus 4. You have two different choices here. You could try to get a common denominator in the bottom and then multiply by the reciprocal. Or you could just multiply everything by x plus 5 since that is an LCD on top and bottom. So the big thing here is realizing you have to do it to the -4 as well because it's everything on top, everything on bottom. So this cancels out, this cancels out. So on the top I have a 2x. On the bottom I still have an x right here, but I need to distribute this -4. So that's -4x and -20. So this is 2x over -3x minus 20. And that would be my composition. So that is f of g. Now, the domain part of this, if you're doing a composition, whatever you plugged in, you can't let that equal 0. So you have to throw out -5 because of that. You're also going to have to throw out whatever makes the final answer 0. So that would be add 20 and divide by -3. So we also would need to throw out 20 over -3. So for the domain of the f of g, it's -5 and -23. Both of those values are undefined because of the way this is structured. Any questions on 20C? Okay. I appreciate you guys coming on and doing this. I'm sorry I had to do it on Saturday. It has been crazy trying to figure out how to schedule all of my different courses for review sessions. Um, so I'm going to post this to Blackboard. I'm going to post both the document, the PDF with the writing on it, and I'll post the video to YouTube and link it through Blackboard under the same announcement. That way you guys can reference everything in one point. If you do think of something else you want to ask me, don't feel like you can't email me tomorrow. I could still do a short video if it's nothing too, elaborate. If most of the questions from the review are really the only things you should be focused on right now. If you know this review backwards and forwards, you should be good on the test. And I mean, I know that anxieties and stuff set in, but this is the material you are responsible for. So on Monday, we will have 13 questions from the 30, and then the next time we come, there will be 12 questions plus a choice of 2 different questions you could use for the bonus. And the bonuses are already on this review. So everything, all 27 possible questions that show up on the test come from these 30. So there's only 3 of them that get thrown out. All right. You guys have a good night. And like I said, I'll get this posted. It'll probably take about an hour or two for the video to format and upload, but it'll be up there as soon as I can get it. Okay? All right. Have a good night.